Okay, this is section 1 on chapter 11, which we're starting the 3D coordinate system. So normally when we graph, we're graphing in the two-dimensional system with the x and y axis that creates our coordinate plane. It's the x and y axis splits it up into 4 pieces, which are the quadrants. Now that we add in the z part of our coordinate system, that's what makes it three-dimensional. We have 3 planes, and that means we're going to have 3 parts to our locations of points. It's going to be x, y, z, which is an ordered triple. The picture on the left-hand side is like you're looking into the corner of a room. And if you imagine the blue and the pink are the walls that meet in that corner, and then the gray is the floor. And if you can imagine that there's another room below, there's a room to the left, to the right, behind. So we've got 8 different views that we could look at with the 3D coordinate system. So the pictures on the right show the different octants of this coordinate system, and we're going to look at what value each part of the ordered triple has, if it's positive or negative, in those octants. So in octant 1, we came forward on the x-axis, to the right on the y-axis, and up on the z-axis, so that would be positive, positive, positive. When you move back into octant 2, this is where it's negative on the x-axis, we moved backwards, right on the y-axis, and up on the z, so that would be negative, positive, positive. Octant 3, we've moved back on the x-axis, to the left on the y-axis, and then up on the z, so this would be negative, negative, positive. Octant 4 is forward on the x-axis, left on the y-axis, and up on the z-axis, so this would be positive, negative, positive. Okay, now we move below. Octant 5 is going to be forward on the x-axis, to the right on the y-axis, and negative on the z. So it's going to be positive, positive, negative. Octant 6, it's going to be back on the x-axis, to the right on the y, and then down below on the z. So that's going to be negative, positive, negative. Octant 7 is going to be back on the x-axis, to the left on the y, and down on the z. So this is going to be negative, negative, negative. And then last, octant 8 is going to be positive on the x, negative on the y, and negative on the z. Okay, so you've got to memorize where things would be in the 3D coordinate system. Now when we're plotting these points and identifying the location of these points, it can be a little bit tricky if you have a hard time visualizing three-dimensionally in your brain. So it takes a little bit of getting used to. So let's look at example 1, and we're going to find the ordered triple for these 4 points A, B, C, D. Okay. Now, in the picture, you're going to see these dashed lines that connect the parts of the x, y, and z axis to give us help figuring out where these points would be located. If they didn't put some type of indication on here, we're looking at a 3-dimensional representation, but on a 2-dimensional surface. So it kind of looks a little confusing. So without those dashed lines, it might be difficult to figure out where these points are located. So let's start with point A. So we start on the x-axis, and we see that they've come forward 2 spaces. So that's 2 on the x. Then they've moved to the left on the y-axis 3 spaces. So that's going to be negative 3 on the y. Then to get the z coordinate, it'll be easier if you take your fingers and put your thumb on the x that connects where the x and y intersected, and your first finger on the point of A. So you can use that as a measurement. And then take that measurement and line it up on the z-axis to see how many spaces up that would be. So with my fingers, that shows to be about 3 spaces. So that would be up 3 on the z-axis. Same thing for B. We start on the x-axis. They went backwards 2 spaces, so that's negative 2. They went to the right 6 spaces on the y-axis, positive 6. And then to get the z again, I'm going to take my fingers and I'm going to measure from that x to the B point. And then I'm going to take and measure that up against the x-axis, and that's about 2. For C, we've come forward 1 space on the x-axis. We've moved to the right 4 spaces on the y-axis, and then notice it didn't go up or down any, so that's 0 on the z. So the location for C would be at 1, 4, 0. Okay, now for point D, came forward 2 spaces on the x-axis, right 2 spaces on the y-axis, and then down, if I take my finger and measure about how far down D is, and then compare that to the z-axis, that looks to be about -3. Okay, so if you're identifying the location of an ordered triple, use this technique of following the dashed lines and then use your finger for the z. If you are graphing the points yourself, which there will be a couple on your homework that you graph, draw in these dashed lines and then approximate z with your fingers as well. Okay, next we're going to be finding the distance in space. So if I have 2 points floating out in space somewhere, I want to find the distance between them, I'm going to use the distance formula. This distance formula looks a lot like the previous distance formula, it just adds in another z component here. So the distance is the square root of x1 minus x2 all squared plus y1 minus y2 all squared plus z1 minus z2 all squared. Okay, so in this example I have 2 ordered triples. A is located at 1, 0, 2, and B is located at 2, 4, -3. So we're going to find the distance between A and B using this formula. So first step is to plug in these ordered triples into the formula. And I'm going to say that the A's represent the 1s, so x1, y1, z1, and B's represent the 2s, x2, y2, z2. So I have that the distance equals the square root of 1 minus 2 all squared plus 0 minus 4 all squared plus 2 minus a -3 all squared. So using order of operations, I want to simplify in the parentheses first and then we'll work our way out. So in the first set of parentheses, 1 minus 2 becomes -1 squared. 0 minus 4 is -4 squared, and then 2 minus a -3 becomes 5 squared. Now we can square each of these terms, so it's still going to be the square root of 1 plus 16 plus 25. Then I can add these 3 terms together. 1 plus 16 plus 25 is 42. So now I need to take the square root of 42. You can simplify the radical, or since this is distance, we're just going to approximate how much that is, and it's about 6.48 units. Okay, so now we're going to look at the midpoint formula in space. Again, it looks a lot like the previous midpoint formula. And remember, midpoint is just an average. We've got 2 points floating out in space, and we're trying to find out what's halfway between them. So you always just add the components and divide by 2. So we have C is located at 5, -2, 3, and D is located at 0, 4, 4. So I'm going to plug these in. The midpoint is going to equal 5 plus 0 divided by 2, -2 plus 4 divided by 2, 3 plus 4 divided by 2. And remember, your answer is going to be an ordered triple here, so keep it in parentheses and then commas in between. So I'm going to add or subtract the numbers on the top. So this will be 5 over 2, 2 over 2, 7 over 2. And then if anything reduces or you can divide anything out, go ahead and simplify. The midpoint for CD turns out to be at 5 halves, 1 7/2. Okay, in example 4, we're going to show that ABC is a right triangle. So I have 3 points floating out in space. A is at 0, 0, 2. B is at -2, 5, 2, and C is at 0, 4, 0. So to verify that it's a right triangle, first thing I'm going to need to do is find the length of each side of these segments. Okay, so to find the length, that's the same as finding the distance. Once I know the length of each side of this triangle, then I can plug it into the Pythagorean theorem to see if it is a right triangle. So we're going to start with the distance from A to B. The distance from A to B is going to be the square root of 0 minus a negative 2 squared plus 0 minus 5 squared plus 2 minus 2 squared. So when I simplify in parentheses, this is going to be the square root of 2 squared plus negative 5 squared plus 0 squared. So then 2 squared is 4, negative 5 squared is 25. When I add these together, the distance from A to B is going to be the square root of 29. And I'm going to leave this as the square root of 29 because I know in the end I'm going to wind up plugging it into the Pythagorean theorem. Okay, so now we need to find another segment or another two pieces of this right triangle, or what we think might be a right triangle. So we're going to find the distance from B to C. So the distance from B to C is going to be the square root of negative 2 minus 0 squared plus 5 minus 4 squared plus 2 minus 0 squared. So this is going to be the square root of negative 2 squared plus 1 squared plus 2 squared. So the square root of 4 plus 1 plus 4 will simplify to the square root of 9. And again, I'm going to leave it as the square root of 9. Okay, we've got one more side to do, the distance from A to C. So from A to C, this is going to be the square root of 0 minus 0 squared plus 0 minus 4 squared plus 2 minus 0 squared. So this will be the square root of 0 squared plus negative 4 squared plus 2 squared. So that's going to be the square root of 0 plus 16 plus 4. When I add those together, that's going to be the square root of 20. So now I'm going to take all three distances, or the lengths for all three sides of my triangle, and I'm going to want to plug them into the Pythagorean theorem to see, is it a right triangle? Okay, and it may be difficult to figure out, okay, which of these segments goes where? I know the Pythagorean theorem is a squared plus b squared equals c squared, but what goes where in each of these? So to remember, in a right triangle, the longest side is always going to be c. Okay, so when I plug this in, I'm looking at the longest side and whatever's the bigger number underneath the square root, and I'm going to put that in place of c. So if I plug in and I say the square root of 9 squared plus the square root of 20 squared equals the square root of 29 squared. And we know that taking the square of a square root will cancel out. So this is going to be 9 plus 20 equals 29, which is a true statement. So since that's a true statement, then yes, this is a right triangle. And you're not going to have a yes or a no answer here. It's just showing your work to verify that it is a right triangle. Okay, now we're going to look at the standard equation of a sphere. Okay, so a sphere in 3 dimensions. So this equation should look a lot like the equation of a circle. X minus h squared plus y minus k squared. And then now we have z minus j squared equals r squared. So the center is HKJ, and the radius is going to equal R. So on example 5, they give us the center and the radius, and they want us to write the equation of the sphere. Well, remember, when you plug in the center, whatever sign that is for the center, when you plug it into the equation, it's just going to be the opposite sign. That's why the minuses are there. And then when I plug in the radius, I'm going to square it. So this will be x minus 2 squared plus y minus 4 squared plus z minus 3 squared equals 3 squared. Now I'm not going to FOIL out the x, y, and z portions of this. That's just going to make it a messy equation in general form. We're going to leave it in standard form. The only thing I'm going to change is the 3 squared on the end. So x minus 2 squared plus y minus 4 squared plus z minus 3 squared equals 9 is the equation of this sphere. Okay, so this one's going to be the opposite. This one, they're giving us the equation of a sphere, and they want us to find the center and the radius. And notice that this equation is not in standard form. This is general form. It's all expanded out. So the same way we worked when we were doing conic sections, we want to group the x's, group the y's, group the z's, and then constants need to go on the other side. So I'm going to put 9x squared minus 6x plus 9y squared plus 18y plus 9z squared equals negative 1. Okay, then I'm going to look at each variable and I'm going to see what I can factor out of each of those. So when I look at the x's, I need to factor a 9 out because that's the coefficient of the x squared. Same thing for the y squared. I'm going to factor a 9 out of the y's and then a 9 out of the z's as well. So when you do that, you're going to leave, I'm going to group those together and then I'm going to factor that number out. I did it in 2 steps, just so you can kind of see, okay, just the x's, just the y's, just the z's. So here's where I factored out the 9's from each of those. Now when I factored out the 9 from the negative 6x, that's where it might get a little tricky. Just think of it this way. You're taking negative 6 and dividing by 9, so you can just reduce negative 6 over 9, and that reduces to negative 2 over 3x. Notice I left a space because I'm going to have to come back and complete the square for each of these. It worked out for the y's that when I factored out a 9, I was just left with a 2y there, so that one's not very ugly. Left my space. For the z's, it was just a z squared, so factoring out the 9 didn't change much there. Okay, so now we need to complete the square. So remember, it's the number in the middle divided by 2 and squared. So if I take negative 2 over 3 and divide by 2 and square it, then I'm going to get 1/9. So think of it this way. Negative 2 over 3 divided by 2 is going to become negative 2 over 6. No. Yes, negative 2 over 6, which reduces to 1/3, and then 1/3 squared is 1/9. Sorry. Okay, same thing for the y's. 2 divided by 2 is 1, 1 squared is 1. And then I didn't have to complete the square for the z's. Now remember, whatever number we add on the left, we have to add on the right-hand side. So I do 9 times 1/9. Well, that's just going to be 1. And then 9 times 1 is 9. So I really added 10 to this equation. So I did that on the other side, had to get a little smaller to fit this in. On the right-hand side now, I have my negative 1 plus 9 times 1/9, which is really just 1. Plus 9 times 1, which is 9. Okay, so I'm going to go to another slide where I've simplified that and added all of that together. So the negative 1 plus 9 just turns out to be 9 over there. And I went ahead and simplified on the left-hand side as well, because when you factor a trinomial, this is a perfect square trinomial, it's going to factor to whatever the number was before I squared it. So remember, I did negative 2 over 3 divided by 2, and that reduced to 1/3. So that's why it's x minus 1/3 in parentheses. Same thing for the y's. It was 2 divided by 2, which is 1, so that's why it's y plus 1. Okay, now if you remember, we want this to equal 1 on the other side, so you can divide everything by 9 if you want to. Notice how we have all those 9's out there on the front. So that's going to reduce to x minus 1/3 all squared plus y plus 1 all squared plus z squared equals 1. So now that this is in standard form, I can find the center and the radius. So when you pull out the center points, remember you change the sign. So this is going to be 1/3, negative 1, 0. And then the number on the end is the radius squared. So if I take the square root of 1, that's going to be 1. So our center is 1/3, negative 1, 0, and a radius of 1 for this sphere.